In this video, we're going to show you how to derive the length of this polar curve. In the previous videos, we show the equation calculating the length of the polar curve, and we denote it to be L, the integral going from alpha to beta. That's the theta, the range of the theta, square root r prime square plus r square d theta. Right? So we derive that. Well, how do we use that equation and plug it here so we can find the length of this curve going from 0 to 2 pi? Right. So first we know that it has something to do with the r prime and r squared. So let's find r prime. R prime dr d theta, in another way of saying it, will be minus 2 sine theta, and we square that will be 4 sine squared, and r squared will be 4. 2 times 2 times 2 is that 8 cosine theta plus 4 cosine squared theta. Alright, so we go ahead and do it right away, right? We don't have to set it in the integral anymore. So r squared plus r prime squared, well, you know that sine squared plus cosine squared, that is just 1. So we have 4. 4 plus 4, that's 8. So we have 8 plus 8 cosine theta going from 0 to 2 pi d theta. Alright, so what are we going to do about this? Well, we know there's an 8 here, 8 plus 8 cosine, so we might try to pull out an 8, right? Well, before we do that, let's just see something a little bit here. We see that this limacon is quite symmetrical. In fact, it is symmetrical. According to the rectangular that we derived in the previous videos, we show that they are symmetrical according to the cosine, the graph of cosine. It is symmetrical, and therefore each half of this is symmetrical, meaning each portion, each each length, and when you chop this in half, each length is equal to one another. So, in other words, we can just calculate from 0 to pi and then times it by 2. But we don't have to go from 2 to 2 pi, because why do we even do that? The reason behind it is because sometimes within the interval from 0 to 2 pi, cosine might get cancelled, right? So cosine might get cancelled when you have going from plus to minus and then minus to plus. It might get cancelled, so it's best of interest not to oversimplify the integral. We may try to manipulate the symmetry a little bit, so that we don't have to run into those issues. The issues that we face that may bring us some hardships later on. So, with that being said, we can change this from 2 pi to just pi, and we times it by 2. Alright. So then we can go ahead and pull an 8 out. So the square root of 8 is 2 square root of 2. Right? So 2 times 2, that's 4. Square root of 2, 0 to pi, 1 plus cosine theta d theta. Alright. Well, we know this is an identity. We know that cosine squared theta go to 1 plus cosine 2 theta over 2. Okay, so how is that even connected to this? We have a 1 plus cosine, we don't have a 1 plus cosine 2 theta, but you can think of this as theta over 2 times 2. You can think of this as theta over 2 times 2, right? Alright, so we have some light there, so we can think of this as just cosine square theta over 2, therefore will equal to 1 plus cosine times this by 2, that will be cosine theta, right? Over 2. And if you're concerned about this, you don't know about this, I didn't see, you can go ahead and work on it using this following symmetry: sine squared theta plus cosine squared theta equal 1, and cosine squared theta minus sine squared theta equal to cosine 2 theta. So using these two following identities, it will follow to give you this symmetry. Just plus those two together. Alright. So we have this, and we plug in there, so we know that this is 1 plus cosine theta, that is 2 cosine square theta over 2 equal to 1 plus cosine theta, right? We have a square root, right? So there will be square root of 2, right? So this square root of 2 square root of 2 times cosine squared, but then the square roots, that will become the absolute value of cosine, right? So you can say absolute value cosine theta over 2 times d theta, right? Okay, so what are we going to do about this? Well, we know that since we have absolute value right here, so theta, so we know that theta going from, we know that the interval theta going from 0 to pi, alright? So therefore, theta over 2 will be going from 0 to pi over 2. Okay? 0 to pi over 2. Because you just divide all of them by 2. Right? So therefore, theta over 2 will be greater than 0, but less than pi over 2. So any values in this interval, you plug in here, cosine, therefore cosine will be positive, right? Because we know that from 0 to pi over 2, cosine is always positive. So we can go ahead and get rid of this absolute value. Right? So that we have cosine theta over 2. Okay. So we know we take this in mind. We're going to go ahead and write on when to do a problem. You need to write out this interval so that it reminds you what is the interval, so that we don't have to deal with all these absolute values and taking the positive and negatives, taking the interval and everything as such. Okay, so we pull out my square root of 2. This become 2, become 8. That'll be sine over 2 times 1/2, right? I'm sorry, times 2. Go from 0 to pi. Okay. This is 16 times sine theta over 2, right? So you put in pi in there, sine pi over 2, that's 1. So you have 16. Putting 0 in there, that's sine 0 is 0. Therefore your answer is 16 unit length. Alright, so this is 16 is the answer for the length of this entire Limacon. Thank you very much.